So I'm going to start with the high-fidelity simulation that I think is going to make a huge impact in the future, actually in the near future. If you look at the Boeing 787 and zoom into the engine is a very complex machinery. And if you look into the engine, especially if you look at the first stage of the turbine blades, the first stage of the turbine blades has to endure all the heat that comes out of the combustor. And the heat is capable of melting any metal out there. So the turbine blades has to be designed to provide a cooling film very close to the surface of the metal to cool the blades enough so that it doesn't melt and doesn't suffer from excessive thermal fatigue. So this is the type of simulations we do on the trailing edge of this turbine blade. And this is the kind of high-fidelity simulation that is going to make a huge impact in the future. Because this kind of simulation, it starts from first principle. So instead of starting from data that is measured during experiments, we start from first principle physics that we know is correct. And it simulates all the phenomena that people use to model. For example, the transition of the turbulent boundary layer. And you can see after the transition, the heat flux increases by a huge amount, almost a step function. And to trying to capture the transition location, people who are doing modeling has worked for decades. And the recent progress is really to use high-fidelity simulation to capture this from first principle. All the other approaches are not as successful as just using high-fidelity simulation. So the kind of research I'm doing is trying to make integrated multidisciplinary high-fidelity simulation usable for design. Right now, we can perform these high-fidelity simulations, but most of them are used for scientific purposes, not for engineering purposes. The barrier to use them for engineering design is what I'm going to be talking about later, and I'm going to show you what kind of mathematical research we can do to break that barrier and fully expose the potential of these high-fidelity simulations to do engineering design. If you have watched the movie Matrix, that is what I want to make it happen. That is, you should be able to engineer, should be able to go into a virtual world that has the full reproducing the physics of the real world and do engineering design in the virtual world with much lower cost and much lower risk and much faster turnaround time than what you have to endure by doing design experiments in the real world.